Good day guys, this is your tutor engineer. Today we'll be doing more lessons on graphs. So let's start. In the diagram below, the graphs of the following functions have been sketched. This is the function, the general function of the graph of f of x, which is a parabola. The general function of the graph of g of x, which is the hyperbola. The graphs intersect at A, and the turning point of the parabola T lies at the point of intersection of the asymptotes of the hyperbola. The line x is equals to 2 is the axis of symmetry of the parabola. Okay, so the first question says, determine the equation of f in the form of y is equal to this general function. So let's start with that. So basically what we have the turning point. There's the turning point there, x is 2, and then y is 1. That means 4.1. You're going to say y is equal to ax minus the turning point x coordinate squared plus the turning point's y coordinate. So we're also been told that the graph passed through point A, so we can use point A to solve for A, this variable here. So on point A, y is 3, x is also 3, therefore we can easily solve for A. A is equal to 2. That means you can write the function. We know that A is 2. Then we'll have x minus 2 squared plus 1. So we've answered question 4.1. Now let's go to 4.2. Determine the equation of g in the form of y is equal to this general function. Okay, let's write here 4.2. Y is equal to a divided by x minus the x coordinate of the turning point, which is 2, plus, now in this case the x is the x equal to 2 is the vertical asymptote, and y is equal to 1 is the horizontal asymptote. So here is the horizontal asymptote. Also, the graph of g passes through point A, so the y coordinate is 3. We can solve for A. The x coordinate is 3. A divided by 1. A is also 2. That means you can write in this format y is equal to 2 divided by x minus 2 in bracket plus 1. Okay, so let's go to equation 4.3. Write down the range of f. So the range of f will be y is greater than or equal to 1. Because of that y coordinate at the turning point, where y is the element of real numbers. Okay, equation 4.4. Given the equation of p of x, give the equation of p of x if p is the graph of f shifted 1 unit up, sorry, it's 1 unit right, and then 3 units up. Okay, so we know that the graph of f of x, we've worked it out under 4.1. Let's rewrite it. That means the graph of p of x, if we are to shift the graph to the right, that means by 1 unit you need to subtract 1 plus 1. And then if we're shifting the graph up, you need to add 3 because we're shifting up by 3 units. Okay, so p of x this is the graph for p of x. Okay, so now 4.5, determine the values of x for which g of x minus f of x is greater than or equal to 0. So it's going to be this region here. Let me choose a color, yellow. So this is the region where g of x is kind of greater than f of x. This is the region here. Okay, so we can say x is greater than or equal to 2, but x is less than or equal to 3. Okay, so now let's go to the next question. Question 5, consider the function. Okay, this is actually f of x is equal to minus 2 x to x minus 2 to the power minus x plus 1. For 5.1, calculate the coordinates of x and y-intercept. Okay, let's choose a different color for that. Okay, so in order to find the x and y-intercept, okay, let's call it 5.1. For x-intercept, we know that y must be 0. So solving for x, basically we can rewrite this as 2 to the power minus x equals 1. You know that 1, you can also rewrite it as 2 to the power 0. So basically we're going to have x is equal to 0, x is 0. That means the x-intercept is 0, 0. And then for the y-intercept, x is 0. So we're going to say minus 1 plus 1 is 0. The y-intercept is also 0, 0. Okay, 5.2, give the equation of the asymptote of f. So that is the asymptote there. So we're going to say y is equal to 1 is the asymptote. 5.3, sketch the graph of f. We already have the x-intercept and the y-intercept. Let's choose a different color. X, y. Okay, so since our graph is negative on this term, we know that it's going to be facing downward. It's going to be like pointing this way. So let's write the asymptote. We set the asymptote y is 1. That means our graph will look something like that. To infinity. You can name it graph f. So that's the answer for 5.3. Then 5.4, solve for x if f of x is equal to minus 5. Okay, firstly, 5.4, f of x is equal to minus 5. F of x is equal to minus 5. Okay, so at this point, this is where we're going to start introducing logs. But firstly, we must write 2 to the power minus x is equal to 6. And then we can introduce log both sides. That means you can take minus x to the front. Basically, x is equal to minus log 6 over log 2. So this is approximately 2.58. Okay, so we've come to the end of our today's lesson. If you like my video, please subscribe. Stay tuned on the next video where we'll be doing more lessons on graphs. Cheers.